Oh my gosh, I'm coding. Wait, yes. Wait, can my screen visible? Let's check the stream. Hopefully, the goal is that I stream and basically no one joins, and so I'm just streaming to myself. I'm just coding all by myself. Um, but I have the added incentive, like that. Hey, um, I haven't done YouTube in so long. That's weird. That's me. Okay. So what project am I working on right now? Currently, I am working on research. So I'm like kind of vibe coding. Vibe coding. Um, this. So basically, my lab has this thing. This thing called AGL score. This is my PI, Professor Duke. And he made this pretty good description. So, like if we look at like a molecular chart or molecule, whatever. If we look at a molecule, we can see this kind of inherent graph structure, right? You can imagine this is like, if you know mathematics, this is like inherently an adjacency matrix, sort of. And so from that, you can make these adjacency matrices, and then a byproduct of that is your Laplacian matrix. And they give you somewhat similar eigenvalues, but they turn out a little bit differently. Either way, you get important features related to the graph. And so, you know, you imagine you have an algebra, like it's a naturally occurring algebraic graph. And so you should be able to extract some meaningful features from those graphs. And so how we do this is using spectral graph theory. And so using spectral graph theory, which is like this thing, right? Maybe not. So, yeah. So using spectral graph theory is basically looking at these two types of matrices and then getting the eigenvalues and or eigenvectors of those matrices. And those give you an inherent frequency of the graph and tell you something about the connectivity or lack thereof connectivity. And so you get like a spectrum, right? And so obviously between different graphs, that the number of frequencies you're going to get is going to differ because your connectivity is going to differ. And so what we do is we take all of those frequencies and we take the certain features like summation, squared sum, max, min, number of connections, what have you, right? And essentially we save those features and then give those machine learning models. I don't understand it either, man. Whatever. And so currently I'm waiting on this to run. So I've made a lot of it's vibe coded. Like a lot of it's vibe coded. Not gonna lie. Um, I want to say I did a lot of it at the start, like making simple stuff like this, and filtering, yeah, filter position, and also getting eigenvalues and this kind of thing. But like, get Adam, I didn't do this. So we make bipartite graphs as well. And so I'm trying to speed it up right now because currently it's all in Python, and you can't use multi-threading in Python intrinsically. Um, like the script itself, how we calculate everything, is in Python, and we can't use multi-threading. And since we're doing these large matrix calculations and eigenvalue calculations, it's very frustrating. So as you can see, I am testing the. I mean, the speed is astronomically larger and better. But like so for this number of complexes, I'm able to process it in 270 seconds. Granted, I'm like it's using OpenMP or whatever. I don't really know. OpenMP, whatever this does, I'm not really sure, but it essentially allows it to just like jump through these pairs using so because it's bipartite, it can jump through every pair just like using every different core, and that makes it like 10 times faster. I really don't know why, but I'm not complaining. So you know me. Yeah. Well, you don't know me. This is my first stream. I don't know what I'm talking about. Um, I actually do need to look into like different algebraic graphs. Oh yeah, okay. And so the plan I plan to take this in, which is sort of I think already been not done with this, but what we can do is so adjacency matrix are undirected, right? But that doesn't necessarily mean um, that doesn't necessarily mean that like how do I illustrate this? Wonder. I don't know. I feel like airplay. Okay. See how this works. So you kind of get this. Wait, shoot. I don't think no. This is just me watching my own stream. Yeah. So okay, wait. Let me see if I can do this. I have really sloppy handwriting, so if I don't know. So let's see. I don't want to mirror it. Can I airplane? We'll see if that works. Don't think that worked. Okay. Open airplay. Screen mirroring. I don't want to do screen mirroring. Like, I don't want to. I feel like there's a how to put on like okay, wait. Casts Apple devices to screen Linux. I feel like this is a thing. Ubuntu desktop. UX play. Let's see if that's a thing. don't think it's a thing for MacBooks, but oh, it is. Okay. Let's see. Maybe. Yo, chat, say what's up right now. Okay, I guess that's not a thing. Um. I guess not. Oh shit. Okay. Well. Mirror. I don't think that's a thing though. I don't want to use it as a second display. Hey. This doesn't matter too much. We'll see if OBS likes it. Probably won't. Let's see. Okay, so I don't want to use an extended display. Okay, well, that's not what I wanted either. I don't know why it's I don't want to use it. I want to mirror. Oh, this sucks. Maybe I can cast it. Oh, let's see. There we go. Okay, you can see that. Perfect. Okay. So we have like a molecule, right? And we'll just say this is vertex 1, 2, 3, 4, right? So you have those vertices. And so you can think of an adjacency matrix like the following, right? So we can say this is 1, this is 2, this is 3, this is 4, and these are the the vertices, right? 1, 2, 3, 4. All right. So we have the vertices. And so with an adjacency matrix, if we have 1 connected to 2, we're going to have a 1 right here. And then we're going to have 2 connected to 1 as well. So 1 right here and a 0. And so with an adjacency matrix, these can never be connected eye to eye, right? Unless you have like a loop, which is a thing. But in molecules, you don't ever have that. So if you have like a loop, so if we have like connects to itself, then we would. But that's not a thing really in molecules. So we'll brush over that for the time being. So we have 1 there, and so we can follow that kind of pattern. So 2 connects to 3, and 3 connects to 2. So 2 connects to 3, 3 connects to 2. We have a 0 here, 0 here, 0 here. And same thing, so 4 connects to 3 and 3 connects to 4. And so we kind of get the following pattern, right? And so we have an adjacency matrix, correct? And so this is our adjacency matrix. And so the Laplacian is if we took, so if we said this is the adjacency matrix, and then we took like the negative of the row wise sums. So basically Laplacian makes it so the summation of each column, you can't see what I'm doing, the summation of each column is equal to 0. So I don't know what that's called again. I don't think that's orthonormal. Maybe it is. I don't think that makes it an orthonormal basis. I don't think so. Maybe it does. I don't think so. Anyway, point being, that's what it does. Okay. So, moving on. So for molecules, I don't know. So for molecules, you have, this, whatever. Where am I going? So for molecules in particular, with organic molecules, you can the electrons are kind of shared between all of your different molecules. But with that, you get kind of these undirected matrices, right? And so if we have a organic molecule, I don't really know what that would be. Like, let's say there's like a benzene ring, right? It's connected to like a OH group. It has like two OH groups or something. I don't even know what kind of molecule this would be. I'm not drawing the hydrogens. Yeah. And so let's say it connects to two OH groups and it has like an R group over here or something. Whatever. Let's say it has that, okay? And so we get some adjacency matrix out of it. And so because of the kind of organic structure, commonly you're going to see that throughout the entire, there's going to be like differences in electronegativity, for example. Like there's going to be more electronegative action probably around these OHs, because a lot of your energy right here, or a lot of your electronegativity is kind of divert, or it's kind of the same, right? And so also these kind of balance each other out slightly. Obviously, there's going to be like a dipole moment in this direction, kind of, but not that way or that way. Yeah. Okay. And so whatever this R group does can change the behavior of the molecule. It doesn't really matter though. Okay, but point being is, because of the structure, the adjacency matrix is going to be kind of able to describe it pretty accurately. And that's because it acts more like a undirected graph, right? Where the direction of the graph, or in this case, let's consider them to be the direction of the electrons, isn't going in a specific direction, right? There's not really a donor or acceptor in this group, right? It's not like an acid, or it's not like a transition metal. So there's not really a donor, or there's not really an acceptor group or atoms in this, which makes it really easy to represent it, right? Because you don't, if we had to direct it, it would have to be a lot more algorithmic and indeterministic. You want it to be deterministic if you're making a directed graph, or else you won't get consistently similar features. But point being, undirected. So this would probably end up being an undirected graph. But point being is, what happens if we make it directed? All right, obviously that changes a lot of things, right? Because if we say, okay, the electrons are going from 1 to 2, so from 1 to 2, so then it becomes a 0. So if we direct it, then it makes 1 to 2, right? And then 2 to 3, right? So it's not 3 to 2 anymore. So this becomes a 0. And then 3 to 4. So then 3 to 4. So then this becomes a 0. And so that's going to change dramatically your eigenvalues. And also this is now a upper triangular matrix, which makes it easier to solve. But regardless, right? Yeah, you're gonna kind of. It's actually gonna. I think it's gonna become very imaginary and very disgusting to solve for. Yeah. Okay. Some of the eigenvalues of this matrix will be horrendous, but that's besides the point. So, um, but basically, the directed graph is going to dramatically change the eigenvalues, right, and the output. And so if you're making a directed graph, you better have a damn good reason to do that, right? An undirected graph, I would say, is very safe, right? Especially when it comes to molecules. It doesn't make any assumptions about the molecules or the direction of the electron flow. Um, I mean, it doesn't have to be direction of electron flow. It could be like something else. I don't really know. I guess like bonds, maybe. I don't know. The direction of a bond, or dipole moment. Yeah, it could be that. So if there's a dipole moment on two bonds, you could represent that. Yeah, you could do a lot of things. You can direct it in a lot of different ways. But point being, is undirected is pretty safe, right? You can represent a lot of things with that. Directed, you need to be very specific on what direction you're going on, or you're going in. And so in this case, in a directed case, what my goal is in my research is to say, okay, if we have one of those complexes that I was talking about earlier, a metal, so some metal, say M, and so M, and it's like, I don't even know. It's like connected to like a Cl. It has like a freaking C, CH3. CH3. This is probably not like an actual thing. Yeah, I don't know. But point being, if we say, okay, the C's are like donors or something, right? They're donating to the metal. Then we have a directed. I don't know if the chemistry is right on that, but then we have a directed graph, right? We no longer have an undirected graph. And so that matters. That will change the output. But it would be more, it should, theoretically, more accurately depict the eigenvalues or the spectrum of our graph and the connectivity of our graph. Actually, I don't know that. So, okay. So let's make sure spectral graph 3. Oh, there goes my mouse. Where? Okay. Shout out to all my fans. Okay, so it can be. Yeah, I mean, I imagine it would be. I don't really know. Okay, well, you have various theorems that you can probably solve for your eigenvalues with. Don't actually know these very well off the top of my head. Interesting theorems. Whatever. I'll probably have to read this later. Okay, we'll start. Or I don't want it to start. We'll put in my motion. Okay, let's see if this is done. This is not done. Oh, this freaking algorithm takes forever. And so something I've been checking is okay, is there a significant difference in the number of features being generated between the two? And there is, with the biggest problem being the fact, I don't even know. Let's see. I mean, that seems accurate. That seems accurate, I will say. So let's see. See if we can even compute it. If you can think that hard. Okay, this is taking forever, so we can look at activity monitor, see what's happening. Okay, so we got 1 million features. Or is that a million? Might be more. 1, 2, 3, 4, 5, 6, 7, 8. Okay, never mind. That is 11 million features. Right? Am I stupid? No, that's 1 million. That's 1 million and something. Wait. No, it couldn't be. It couldn't be. It has to be more than that. Am I slow? 4. Oh no. Wait. 4. That's 8. 8 digits. That's 10. Yeah. What am I? Oh, okay. Oh. God. 11 million features, as I was saying. Oh, there we go. It's done. Perfect. And so, 10x speed up. 10x speed up between this algorithm, the C++ one, and the old one. And you know, that's saves a lot of time if I could get this to compute the same number of features. Okay, not super promising given the fact that I mean, we have to test the gradient boosting, but not super promising. So something I've been doing to do like a cheap. So we have a lot less features, like 10 times less features. So something I've been doing to do like a cheap check of if this is producing. I don't know why it's not producing the same amount. Definitely should be, but it's not. And so I wonder if it's getting the name of the type. And that matters. Maybe if I do type instead. So if we do type, then we might be able to get more of what we actually want. So to analyze all of these files, I'm not going to write a reader, but luckily for C++, there exists something called chemfiles, and chemfiles is very, very useful. Also, I learned how to use bash scripts during this because I was tired of running all of this very slowly. Okay, we'll see if that works. We'll see if this works right now. Because I imagine it should. Oh, yeah, well, that explains that. And so this took 200 seconds. 240 seconds was like 4 minutes. So this shouldn't be too long. And it should be less than that because now I'm using even less. So if we look at the documentation for chemfiles, which is actually kind of shit, not gonna lie. Maybe there's, what is it? Dev docs. I use this occasionally, but if okay, can I search that? I hope chemfiles is in there. Bruh, okay. Well, chemfiles is not in here apparently. That sucks. Eigen 3 is though. That's cool. I wish DevDocs had. So anyway, DevDocs is nice. But as I was saying, so chemfiles.org, very nice C package. It also supports a bunch of different other things. But the main thing I'm using it for is this right here. So format agnostic, so you can just read anything pretty much, which I love. Or anything that's related to like cheminformatics, which is all I do. So it's pretty useful, and it also has like a pretty simple installation guide, and it can be used in Rust, C, C++. I didn't even know it could be used in Fortran, Julia. I mean, yeah, I mean it's pretty useful. And so let's see. And so like the idea is. So we should be able to get type. Nope. Maybe it is the first one. Nope. So you can set type, but you should be able to read it. Maybe it's probably under the read function. Whatever this tutorial is. So yeah, so you provided a function, and then it gives you a bunch of different things you can do with your frame. And so here's your frame. And so with your frame, you can get the topology, or your positions. And so for if you just got called frame on like an empty file, or you didn't have a file, it would return with zeros or empty. But since we have a PDB, we have all this data about the protein. And so with that, when we call topology, I think we get definitions of all atoms in the system, as well as liaisons. Liaisons? What is it?
Liaison.
Liaison. That's not the word they used. Liaison? The communications. Okay, the bonds. An illicit sexual relationship. Well, liaisons. So you get all the liaisons between different particles or different proteins. Only atoms and bonds are stored. Okay, interesting. And so when you call topology, you get a bunch of different things. Whatever. Okay, fine. And apparently you can get the angles too, which is kind of crazy. I don't know how I would get. I guess I'm sure they have a backend for like computing as long as they have the coordinates. But the positions is a different. It's a different class. I mean, I guess it could be accessed by topology, but okay. Well, anyway, so you can get the topology of your frame, or of your. In this case, I'm calling static files, so I'm just getting the topology of my PDB, which I don't really need the whole topology, but it's nice. So if there's more things I need to access, so I can get each atom type line by line, which is fine. It's cool. It works. And we get positions by angstroms. Interesting. Oh, interesting. Guess bonds. That's actually pretty cool. Okay, so apparently if you have a file and it doesn't like explicitly know the bonds, and so for example, like, or actually I have it on my computer. I don't know why I'm doing that. So like if you have an XYZ file, for example, doesn't have any information about your bonds. It only has your atom identity and your atom position in 3D space. And so apparently, I guess if you read it out, you can use topology, or you can use dot guess bonds to predict the bonds. in the molecule, which is kind of cool actually. I didn't know that. Huh. Anyway, so you can do that fun stuff. You can get distance. Yeah. Anyway, I probably need to do more of this distance because I have my own calculation in there, which isn't a bad calculation, but it's probably slower than that. I don't know what their backend is called. I wanted to. Okay. It's a h.p. It's a .hpp file, so I think it's. Let's see if we can find it actually. I wonder. No. Okay. I usually you can click on these things like utility and find it, but I guess not. So there's that. Curious. Jeez. Okay, this is why I don't quote Fortran right here. This is it just looks gross. I mean, it looks very similar though to what I'm already doing, so I guess it's fine. I don't know really who's making it. Probably should have. I mean, it's very, very well done. Dang. So you can curate. Oh, really? Oh, this is interesting. Wow. Oh, I have to keep this in mind. Okay. So I guess while that runs, which I thought was gonna take, now it's taking right now. I might have broke it. It ran though. Right? Yeah, it ran. Okay. Wait, let's see actually. That looks right. Alright, anyway. Okay, so what was I gotta look up? Oh yeah. So now we're gonna move into the next thing I have planned for myself. So now, which is going to be doing some stuff with this. Okay. So another thing I've been working on is making a fintech club at UT. Well, not really. It's more just for me. I want to make money. And so, yeah, I don't know. I guess I'm just going to do fintech stuff. I'm not really all that interested, but well. Actually, I think I'm going to work on something else. Okay. So, okay, instead of that, I'm going to use, I'm going to look at this. Okay, so open face, facial behavior analysis toolkit. So, with this, we can recognize faces, right? And we can recognize pose detection in faces, so gaze tracking. Yes. Okay, so we're gonna download it, and we're gonna try and use it, and see if I can get to work tonight, because why not? Alright, well, that's not gonna work. And so also people are gonna make fun of me for like open face. Using an IDE. Actually, oh yeah, that's right. Okay, so can you see on X open face, and that's in camel case. So see my open face, and so then we can run it. Open face. Bruh. Alright, I'm gonna stop that. I'm gonna delete this. Okay, so we're gonna try one more time. And this time we're gonna make sure that our environment is activated. Now we run it. Yeah, so all those things should be downloaded, but in case they're not, just gonna do it anyway. So now we can get clone. So this is a fun script though. It makes my life easy. I don't know why it's actually taking so long to run. This should not. This is destroying my computer right now. Hello? Yeah. But yeah, so this is why you use multi-threading, because it can actually use a large percentage of your CPU without restrictions. That's always good. Oh god. So many dependencies. So another project I want to work on is, so I wanted to do a gambling bot, but instead now, so I do a lot of different things, as you can see, which, you know, you gotta do a lot of different things to fail a lot, and yeah. So my idea right now is we have a face recognition software that looks at me, tracks attention, and shocks me with dog collar hooked up to Arduino if I don't pay attention to my studies. Very sane idea. So some might think it's a freaky idea, but I say to that, to that I say, it worked for is it Kaylee? It worked for Kaylee, so it might as well work for me. Classic place training, right? And so I'm pretty much a dog. In my eyes, I should be able to get behaviorally manipulated the same way a dog would, getting shocked. And so if I don't listen, okay, what failed? I guess it couldn't find open class. That's sad. Patch experts. So data build. The local copy to bin. Yeah, there's nothing in here. Interesting. Maybe. I think it's not prime. Nope, not even close. Okay. So let me do. No. Let's do make. What? Wait, for real? Oh. Okay, I guess it didn't make it. Okay, let's look at the C make file. It's not finding open blast. Interesting. What if we... So, in this case... There we go. We got the... So we can go to opt. So this is a global folder. This is where Homebrew, if you install Homebrew globally, that's where it's going to go. Which hopefully you do. It's very useful, and hopefully you have your own computer so you can do that. Oven is ready. So I made some stuff earlier. So, shout out Mom, by the way. And so we are looking for open blast, which is right there. Okay. So where to? Oh, okay. Anyway. Yes, it doesn't really work. I don't. Also, all my C++ training, while not being completely, I don't know any data structures. I know like the intro to C++, which is like nothing. I don't really know any algorithms. I know like some. I like 6 months ago I learned how to like do some bit manipulation more than 7 months. So more like, yeah, it's nothing. I know nothing about C++. Everything is pretty much just self-taught. So don't make fun of me if I use a lot of, which, I mean, I guess a lot of people do C++ self-taught, but it's not that bad of a language, I guess. So let's see. So if I do path name, should be able to do something like paths, or paths that, and now do this. Generate step failed, build not, boost cannot be found. Can I find boost found in 5? Is that not the what are we talking about right now? Is this not bigger than, okay, maybe okay, it's the highest. Do I have to, does it have to be, does it I don't think it requires boost 5 point. That's stupid. Bruh. What are we talking about? Found version 1.9. Boost cannot. What do you mean? You literally just found. I said you found it. Am I stupid? Bruh. Open mass library not found. Dog. I really dislike this. Okay. Let's see. Let's see if my favorite friend Gemini can understand this. So maybe loud. But anyway, I think I'm gonna end the stream. Probably it's kind of getting late. Fun times, everyone. Thank you all for joining me. It's just me, I know that. Yeah, I don't know. Nothing I can say. Bruh. Oh my god, bruh. Oh. Where'd I put my phone? Oh, it's in my pocket. values. Um, what? Okay. That was fun. Thank you all for joining me. Have a lovely night. Hopefully, I stream more in the future.